Now, when you are here, click on the clock configuration. Those clock configuration here already got some default settings here that you can basically just load into your program, because this default configuration is based on the board selection that you already select when you are creating a new project. Okay, I'm using the stm32 Nucleo F334R8 board. Now, you might be using a different one, but believe me, the clock configuration is very much similar, although it will have different values loaded by default, because this one of mine here said that the maximum frequency that I can run this chip here is 72 megahertz. Okay, yours might be different, might be more or less. Now, right now, my board is actually on a default of 64 megahertz. Point to prescaler here, where I basically get it say clock divider is not available. To enable it, one of the following RCC models or IPs have to be configured from the pinout tab. So it basically is telling me if I want to have access to basically controlling this, right? All I have to do is basically to enable one of these functions on the pin configuration tab, like what I said earlier. So if I go ahead like this timer 1 source multiplexer here, so if I go back into my pin out configurations and find the timers, right? So I choose like timer 1 and enable this timer. And once we enable it, automatically we're going to see that we'll be able to switch and change to whatever frequency we want here on the timer configuration. So let's go ahead and choose a clock source, right? So let's just go easy and say internal clock source. Right, so when I select internal clock source, there are some other options that must be selected here. Now, this is basically if you want a PWM frequency and all other things. I've got a tutorial out on how to configure the PWM frequency with your STM32. This is basically where you play out, you select your channel and all other things. Now, let's head back to the clock configuration, and you can see as soon as we enable that timer, we now have this option here available where we can basically change and put whatever value we want to put there for our clock. And once you input it, it will have to also look for a solution for you so that this configuration can be able to load in and work accordingly in your system. This is an example one. You can see X2 here. That is your external oscillator with a 32.7 kilohertz of frequency. Okay, so if you want to use a real-time clock, you're going to be depending on this one to clocking for you. The third option will be the LSIRC. Now, this is really it depends on application. Most application, okay, if you are just running a simple application, you can also use this, because this RC basically mean you're going to have a resistance and a capacitor to basically set your timer for your external clock oscillator. So now the accuracy is not the same as having your crystal oscillator running here, right? If you select